Okay, so the next concept that we need to go over is limiting reactant. And so limiting reactant is just what the word says. It's the reactant that limits. So reactant is the substances that go into a reaction. So while we do all of this stuff on limiting reactant and excess reactant and all of this, I want you to really picture doing it in a lab. So I want you to picture that you have two reactants weighed out, okay? You have two, just picture like sand almost, okay? You have two reactants laid out. And you have a certain amount of reactant A and a certain amount of reactant B. And you're asked for which one is the limiting reactant. So the limiting reactant is whenever you put those two reactants together, A and B, you will get a certain amount of product. The limiting reactant is basically the one that runs out. It's the one that limits the amount of product being formed. So when it runs out, you can't make any more product no matter how much of the other reactant you have left, okay? So let's draw a little picture. Say you have some, this is A, and you have some of B, you weighed some out, and you can make C, okay? Well, say I have a little bit of A and plenty of B. Well, just because I have enough of this product does not mean that I can make as much. Even though I have enough B to make loads and loads of C, does not mean that I have enough A to make this amount, okay? So A runs out first, and I can only make this amount of C. So that means that A was my limiting reactant. So if you want to picture this, basically you would now have a beaker full of C. So you have this stuff, but you would also have some stuff at the bottom. This is your leftover B. Okay, if we just want to picture it and try to figure out what's going on, you have one reactant that gets used all the way. That's your limiting reactant. It produces the max amount that it can make, but that's also the least amount of product possible. Okay, and then B is over there. It gets used, but then it has some excess, so it's your excess reactant. Okay, so when we're actually doing this in a reaction, normally our question says, what is the limiting reactant? And it gives you two amounts. It gives you, for this one, it gives you 42.1 grams of C6H6, which is benzene, and it gives you 73.0 grams of bromine. So in the limiting reactants, we have almost like double the work because we have to solve for how much product each of these amounts would give us. So it's like we have two givens, okay? So both of these are givens, and we're going to treat them separately. So your first step of limiting reactants should be the first step that you do all the time, is you want to look back at your equation. You want to look back at your equation, and you want to make sure it's balanced, okay? Because since we're given one reactant and we want to know how much product we're made, we're going from like substance A to substance B, or we're going from a reactant to a product. So we have to have a full balanced equation in order for us to go from one compound to another compound. So let's look at this and just make sure it's balanced. I have six carbons, and I have 6 carbons. I have 6 hydrogens, and I have 5 plus 1, so I have 6 hydrogens on that side. I have 2 bromines, and then I have 1 plus 1, so I have 2 bromines on either side. So luckily, everything is balanced with those coefficients of 1. So I'm going to put those 1s in just so you can see them. All right, so step 1 was to make sure your equation was ready to go, so make sure it's formed and balanced. For us, step 2 in this problem is we're going to actually be working with those givens. So you're going to work with both givens. I'm just going to rewrite them into this equation so that you can see them. So I'm going to color this one in this color. So we have 42.1 grams of this benzene, C6H6. Well, because we're looking for which one is the limiting reactant, it doesn't specify which product we're looking for. So a lot of times this is going to be probably the most difficult part of the limiting reactant, is figuring out where to go. And so I just pick a product, okay? Because the whole point of limiting reactant is to figure out how much this amount of reactant could form. If it had plenty of the other reactant, how much could it form? How much could it form of what? So because these two things are added together and as the reactants, they're going to form these two products. So you have to pick one of the products and just solve for an amount. Now, because this reaction doesn't ask me for the grams of product, I don't have to go that far. I can just pick a product, I'm just going to pick that one, and solve for moles. Okay, so that's going to be 2A, as I'm just going to use that given and solve for that goal. So I have 42.1 grams of C6H6. Well, I want to know, my question is, how many moles of C6H5Br? So the first step is to get out of grams and go to moles of C6H6. Okay, so to know this number right here, this is just the molar mass of C6H6. So you have C and you have H. You have 6 of both. The mass of carbon is 12. The mass of hydrogen is 1. 6 times 12 is 72. 6 times 1 is 6. Together that makes 78. So you have 78 grams of 78 grams of C6H6 and 1 mole of C6H6. So that cancels out my grams, and now I'm in mole of C6H6. I now need, since I'm in mole of my given, I'm in mole of given, I can use this reaction to get to mole of my goal, okay? So I'm just going to use those coefficients. I'm going to put the C6H6 on bottom because it's on top right here, so I'm just going to move it to the bottom. And I'm going to put C6H5Br on top. And remember, when we get to moles, we can use the chemical equation, and we just put those coefficients. And so that gets rid of mole of C6H6, and now I'm in mole of C6H5Br. I know y'all are tired of me saying that. Okay, so when I solve for this, I'm just going to take 42.1 times 1 times 1, and then divide it by 78 times 1. So really, it's just 42.1 divided by 78, and that gives me 0.5397. So I solved for this question mark up here, so I'm going to go fill it in. So that means that this pretty little pink color that comes from 42.1 grams of benzene, it will give me 0.5397 moles of product. Okay. So that is one of the steps for this reaction. Now, a limiting reactant problem is always going to give you multiple givens. So I was given 2 givens. I've already worked with the 42.1 grams. I now need to work with this 73.0 grams of benzene. Okay, and the same thing, to compare these two numbers, I have to solve for moles of the same product so that I can compare these two products. So I'm now going to do 2B. It's going to be the same concept, but instead of starting with 42.1 grams, I'm going to start with 73.0 grams of bromine. Okay, so again, I'm doing grams of bromine to mole of C6H5Br. So I need to get rid of this gram of bromine. So I'm going to put gram here. I'm going to say 1 mole Br2. All right, so grams in a mole, this is just the molar mass. And so this number comes from saying I have 2 Brs and each have a mass of 80 grams. So together this is 160 grams. So this is 160 grams equals 1 mole of bromine. All right, so I am in mole of bromine, and I'm trying to get to mole of C6H5Br. So I'm just going to use this equation. Now that I'm in mole, I can just use the equation to go over here. And so I can put Br on bottom, C6H5Br on top, and I'm just going to use the coefficients, 1 and 1. That gets rid of mole of bromine, and I'm in mole of C6H5Br. All right, so again, the math on this is just 73 times 1 times 1 divided by 160 times 1, or 73 divided by 160. And that gives me 0.456. So we just solved for this question mark up here, so I'm going to go erase it, and I'm going to fill it in. I need more space. 0.456 moles. All right, so now what we do. So our question says, what is the limiting reactant between those two? Well, we solved for, we started with this 42, let me use a different color. We started with this 42.1 grams of benzene. And we said if we had plenty of bromine, okay? If we had plenty of bromine, we could make 0.5397 moles of C6H5Br. We could make all this if we had plenty of bromine. So that was like step one. We did a mass to mole calculation using this given right here. All right, so that's how much that given would give us. Well, then we have to also go to the 73 grams of bromine and say, if we have 73 grams of bromine with plenty of C6H6, we could make 0.456 moles of the product. So because the bromine will only make 0.456 moles compared to the other 0.5397, the 0.456 moles, that is the max amount of product being made, okay? Just because that 42.1 grams of benzene will make 0.5 moles of product does not mean that we can make it because we ran out of bromine, okay? So to answer the question, it says which one is the limiting reactant? Okay, well, whichever one made the lower amount of product. And so this one was our lower amount of product, and it came from bromine. So your limiting reactant in this situation was bromine. Okay, so just to kind of go over everything that we've done, we talked about limiting reactant. We talked about how it's the reactant that runs out first. It's the one that forms the lower amount of product, okay? And then we worked a problem. We worked a problem where we were asked, what is the limiting reactant if we use these two reactants, okay? So when we're just asked for what is the limiting reactant, we can pick a product. I picked the first product I saw, and we just solve for how many moles. We don't have to go all the way to grams. It's totally okay if you go to grams, not a problem. It's also totally okay if you would have solved for how many moles of the other product, HBr, okay? It doesn't matter which product you solve for, you just have to stay consistent for each one. So if you choose to solve for C6H5Br and you choose to solve for moles, then you have to do that for both the 42.1 grams of benzene and the 73 grams of bromine. Say you chose the HBr and you chose grams. Well, you would have had to take the 42.1 grams of benzene and solve for grams of HBr. And then you also would have had to take the 73 grams of bromine and solve for grams of HBr. Okay, so you just have to pick a product and stay consistent with what you're looking for. This is only when it doesn't ask you for a specific product. This one didn't ask me anything about the product. It just said which one is the limiting reactant. So the first step is always to make sure your equation's set up and ready to go. And so the second step was just to take your given and work towards the goal that we created. So you took each given, you took the 42.1 grams of one of the reactant, and you also took the 73 grams of the other reactant, and you worked towards the same goal. You worked towards moles of C6H5Br for both of those two reactants. And then you compared the two answers. You compared 0.5397 and 0.456, and you said 0.456 was the lower number. So therefore, bromine ran out first because it made the lower amount of product. So it ran out. You can't make any more because it's done. So that means that bromine is your limiting reactant.